In this video, we're going to do a couple more examples with complex fractions. And remember, when we say complex fraction, we just mean a fraction in which the numerator and or the denominator involves another fraction. So in other words, we have this overall fraction where we have a numerator here and a denominator here, but either the numerator and or the denominator also involves a fraction. So it's sort of nested fractions or a fraction within a fraction. In this first example, we have this overall fraction here, and our numerator is 1 over x, so we have a fraction inside of our numerator. We also have a fraction inside our denominator because our denominator is 1 minus 1 over x. So when we're simplifying complex fractions like this one, our goal is going to be to get just one fraction in the numerator and just one fraction in the denominator. Once we've done that, then it's going to be pretty easy to simplify the overall fraction. So we already have just one fraction in the numerator, but in the denominator we have this whole number 1 minus a fraction. So in order to get just one fraction in the denominator, what we want to do is find a common denominator between these two terms. In order to do that, we'll have to multiply this 1 here by x over x. When we do, we'll get 1 over x in our numerator, and here in our denominator, x over x times 1 is going to give us x over x minus 1 over x. Now that we have a common denominator, here we have x over x and negative 1 over x. We have x's in both of the denominators. We can combine these two fractions. So what we'll end up with is 1 over x, and then in the denominator here, we'll have x minus 1 over x. Now you can see we have just one fraction in the numerator and one fraction in the denominator. Once you've got that, you can go ahead and simplify this by keeping the numerator the same, so the numerator will stay 1 over x, and then instead of dividing by the fraction in the denominator, we can multiply by the denominator's reciprocal. Remember, the reciprocal of a fraction is just whatever we get when we flip the fraction upside down. So instead of x minus 1 over x, we're going to flip that upside down and get x over x minus 1. So you can see how instead of doing the division, we're multiplying by the reciprocal. So we just flip that upside down, and now at this point, because we have a fraction times a fraction, all we have to do is multiply across our numerators. So 1 times x will give us x, and then multiply across our denominators. X times x minus 1 is going to give us x times quantity x minus 1. From here, even though we've simplified our fraction, we have to make sure that we've reduced it as much as possible. And because we have an x in the numerator and an x in the denominator, we can factor that out. So we'll factor out an x from the numerator, and we'll factor out an x from the denominator. And when we do that, we'll just be left with 1 in the numerator, and in the denominator, x minus 1. Now, of course, we can cancel x over x, that's just going to be equal to 1, and our result is just 1 over x minus 1. If we look at a second example, we have a times x to the negative 1 plus b times y to the negative 1, all divided by x to the negative 1. So remember that our first goal is going to be to just get one fraction in the numerator and just one fraction in the denominator. In order to do that, we first have to deal with our negative exponents. Remember this rule that tells us that if we have x to the negative a, that's going to be equal to 1 over x to the positive a. In other words, we had x to the negative a over 1, that's kind of implied, and we have this negative exponent, negative a. Well, in order to make that exponent positive, we just want to move that x to the negative a to the denominator, and it'll become positive. So when we have a times x to the negative 1, what we can do is say a times 1 over x to the 1. So 1 over x to the 1, or just 1 over x. We just move that x to the denominator in order to make the exponent positive. Same thing here, we get plus b times y to the negative 1, or 1 over y to the 1, or just 1 over y. So we get that in our numerator, and in our denominator, x to the negative 1 is the same thing as 1 over x. Now we have a single fraction in our denominator, but we need to get a single fraction in our numerator. So multiplying the a by 1 over x, we'll get a over x. Multiplying the b by 1 over y, we'll get plus b over y, all divided by 1 over x. Now we need to find a common denominator in our numerator here, because the denominator of this fraction is x, the denominator of this fraction is y. So in order to find a common denominator, we'll multiply this one by y over y, and this one by x over x. When we do that, we're going to get ay over xy plus bx over xy, all divided by 1 over x. Now, with this common denominator of xy, we can go ahead and combine these fractions, and we'll get ay plus bx, all over xy, and then we divide that whole thing by 1 over x. Now you can see we have a single fraction in our numerator and a single fraction in the denominator, which means that we can, instead of dividing the numerator by the denominator, we can multiply the numerator by the denominator's reciprocal. So we just get ay plus bx over xy, and then instead of dividing by 1 over x, we'll multiply by the reciprocal, which is what we get when we flip this upside down. So instead of 1 over x, x over 1. And then we just multiply across our numerators and across our denominators. Before we do that, we can go ahead and cancel an x from the denominator here with the x from the numerator over here, and all we're left with then is ay plus bx divided by y times 1, which is just y, and that's our final answer.